This is my continuing commentary on Euclid Book 7 definitions, and we're going to go with number 18 here. It says a square number is equal multiplied by equal, or a number which is contained by two equal numbers. What does that mean? An equal multiplied by an equal. In other words, this number is equal in size to that one. Or a number which is contained by two equal numbers. That's what that means. Now, the other part of this is to get you to visualize square numbers. One of the things is that we have such problems with, especially in high school mathematics, is that when people see, let me draw this out here, when people see x squared, all they're thinking about is, oh gee, that's some kind of a superscript. You're in advanced math now. If you've made it through to this point in Euclid's Elements, you're way past elementary mathematics. So we got to get you away from visualizing this as some kind of a superscript that means nothing. It does mean something. It is square area. Okay? We're talking about square area here. Get away from this and start thinking of it this way. Every time you see this, you've got to see this. Or otherwise, you'll never get it. Alright? And when you get into things like statistics and physics and anything else you want to get yourself into, if you don't get away from this and start seeing it like this, you're not going to understand it at all. And that's what we're trying to do. We're trying to get you out of elementary school mathematics, starting to get you to see things and visualize it. That's the biggest thing, is to visualize what you're doing. Okay? Now, notice here, I've made this into a 2 by 2 square. You can make this into a 1 by 1 square, whatever you want to do. Okay? You can shrink the size of the square, and you can then multiply the parts. Or you can make the square bigger and multiply the parts that way. Whether you make this bigger or you make this smaller, you're still going to end up with something like this. Alright? You can subdivide a small square into even smaller squares. Okay? And each one of these smaller squares would be known as a unit. Alright? Now, let's say you have a 1 by 1 square. You start making it into a 2 by 2 square. You're going to have to add 3 extra squares to make the 1 by 1 square into a 2 by 2 square. And if you wanted to make this into a 3 by 3 square, you would have to add an additional 5 units to make it into a 3 by 3 square. Do you see where I'm going with this? If you wanted to make a 1 by 1 square, here, let me try to illustrate this. Okay, if you want to make if you had a 1 by 1 square and you wanted to make it a 2 by 2 square, you would have to add, that's the word add, you have to add 3 units. Okay, you'd have to add 3 units. If you want to make this into a 3 by 3 square, you would have to add an additional 5 units. And if you want to make this into a 4 by 4 square, you would have to add an additional 9 units. Mistake. 7. You'd have to add an additional 7 units. And if you want to make this into a 5 by 5, you would have to add an additional 9 units. Okay? So, when you make this a 2 by 2 square, you've added 3 units to the 1 by 1, and then, because you now have 4, you add an additional 5, and it makes the 9. You add an additional 7 on top of that, and it makes the 16, because 9 plus 7 is 16. Okay? And if you add 9 units to 16, you're going to get 25. But so, notice this. All those numbers there are odd numbers. The 3, the 5, the 7, and the 9. Isn't that interesting? When you're adding an additional amount of units to make a square into a bigger square, okay, you're going to be using an odd number. That's a guarantee. You can see it right here. We added 3 units to the 1 to make it a 2 by 2. We added 5 units to the 2 by 2 to make it a 3 by 3. We added 7 units to the 3 by 3 to make it a 4 by 4. And we added 9 units to the 4 by 4 to make it a 5 by 5. And that's what we did. Okay? Like I said, you can make the units smaller. You can make the units bigger. Okay? If you have a small square, you can subdivide the square into even smaller parts. Or you can have a small square and make it into a bigger part. Either way, it works exactly the same way. Now, why do we want you to visualize it as square areas? Because if you're dealing with aeronautics or agriculture or anything like that, you're going to have to start visualizing this as square areas instead of just squares. Alright, because that actually means something to farmers, to people flying airplanes, to people navigating anywhere. Get the idea? So as soon as you take the big step from, oh my gosh, these are just little superscripts, to, oh my gosh, these are square areas, you'll go on a lot further in mathematics. And we're talking about physics, we're talking about statistics. You think it doesn't matter in statistics? You can actually use this to illustrate statistics. Okay? Because you're saying, well, how do we do that with square areas? Well, basically, you're going to use line, pi, and all kinds of other charts. You can use those kind of charts, visualizing all this with areas. And that's what we're trying to get you to do. We want you to visualize math instead of just declaring it as math. That's what I'm trying to do. And hopefully you'll be able to do that. Alright. That concludes my commentary for tonight. I will tell you more in a future video, so I want you to stay tuned.